So let's look at the structure of how we connect core concepts to the global context. If we take the core of this diagram and examine it first, we notice that the concepts are made up of quantum mechanics, molecular bonding, thermodynamics, which involves energy, entropy, and spontaneous change, electrons and chemistry, electrochemistry, and how it relates to the origins of life. Then kinetics, the rates of reaction, and also catalysis that allows us to control those rates by adjusting the chemical mechanism. And finally, nuclear reactions and the issue of imaging and radiocarbon dating and all the aspects that come along with it. So sitting at the core that are developed within each chapter, the links then to the global context provide a remarkable array of very interesting innovative developments. For example, innovative new materials for nanostructures, solar cells, and self-assembly, international negotiations, technology leadership and arms control, human health, molecular, cellular level imaging, low-cost disease detection, technology leadership, electronics, electric automobiles, health systems, national security, the primary energy generation locally, feedbacks in the climate structure. These are extremely important for setting the timescale for irreversibility. And finally, energy production, storage, and distribution. So the question is, how do we link these core ideas that are the concepts within each chapter to this larger global context? Well, we do this by taking these central concepts and connecting them to the global context with case studies. Now, case studies are extremely important for quantitatively linking these ideas that in isolation are intrinsically interesting, but when they're linked to a global context, they become far more fascinating. And these case studies establish the spokes that link this hub of the central concepts into this larger global context. So let's examine how we connect these concepts to the global context. If we run along one axis that we define here as concepts, we have, as we've mentioned before, thermodynamics, electrochemistry, quantum mechanics, bonding, kinetics, and nuclear, and that many people are experts in each one of these topics. But there's another axis that's particularly important, and that's the axis of context. How these ideas, how these innovative ideas, how these core scientific ideas couple into this larger global context that we've talked about before. And there are people who are expert at the context. But what's missing and extremely important is the ability to connect directly these concepts to the larger global context. And so this course evolves this growing development linking these two axes. And while it may be surprising at first glance, when you finish this course, you'll be in the 99th percentile in coupling these two. And it's the coupling of these two axes that dominates the strategy of this course and the importance of it.